to the functional division of the CNS. Functionally, the central nervous system is divided into two parts. The two parts are the somatic part and the visceral part. Somatic and visceral. These are the two functional divisions of the central nervous system. First of all, we will discuss about the somatic part of the central nervous system. The somatic part, it innervates structures such as skin and the skeletal muscles of the body. It innervates skin and the skeletal muscles, of the body, and are derived from the somites. They're derived from somites in the embryo. So what does the somatic part do? It actually takes up signals from the body, from the peripheral regions of the body, back to the spinal cord and the brain. It takes information from body, information from the peripheral regions, from PNS to the CNS. That is the brain and the spinal cord. The somatic nerves, they arise in segments. The nerves, they arise in segments along the developing brain and spinal cord. That is, they arise in segments along the CNS in association with somites. This is a neural tube. So what I'm making now is a short section of the embryo, of the developing embryo, and this is the neural tube. Now along the neural tube we have certain structures. Along the neural tube we have these certain structures. And these structures are known as somites. They're called somites. This is the neural tube. So these somites are arranged in segments. They're segmentally arranged alongside the neural tube. And just besides the somites, we have somatic nerves. These somatic nerves, they arise segmentally along the developing CNS in association to the somites. So these are the somatic nerves. Somatic nerves. When the cells differentiate, the somites, they give rise to dorsal and ventral regions. This is the ventral region, and here is the dorsal. Cells that migrate anteriorly, or cells that migrate to the ventral side of the body, they give rise to hypaxial muscles. These are muscles of the limbs and the trunk, whereas the cells that migrate to the dorsal side of the body, or posteriorly they give rise to the intrinsic muscles of the back. They give rise to intrinsic muscles of the back. Once again, the somatic part of the CNS, it innervates skin and skeletal muscles, which are derived from the somites. And what are somites? Somites are segmental structures that are arranged segmentally along the developing CNS. This is the neural tube. These somites are structures that arise segmentally along the neural tube, and they differentiate into, or cells of these somites, they migrate into dorsal regions and anterior regions of the body, or the embryo. The cells that migrate to the ventral part of the body, they give rise to the hypaxial muscles. These hypaxial muscles are muscles of the limbs and the trunk, whereas cells that migrate to the dorsal side of the body, they give rise to the intrinsic muscles of the back. And the somatic nerves, they are segmentally arranged alongside these somites. So these are the somatic nerves that are arising in segments in association to the somites. To get a clear picture, right here, the nerve cells in the anterior region of the neural tube. These are the nerve cells in the anterior region of the neural tube. They extend their processes. Into the anterior and posterior regions of the dermatomyotomes. Now, when I say the word dermatomyotome, this dermatomyotome is a part of a somite. A part of a somite is known as dermatomyotome. Part of a somite is called dermatomyotome. The neurons in the anterior region, or the anterior aspect of the neural tube, they extend their processes into the anterior and posterior, that is the dorsal and ventral regions of the dermatomyotome. Simultaneously, the derivatives of the neural crest cells. This is a neural crest that lies alongside the neural tube. This is a neural crest. The derivatives of these cells, the derivatives from the neural crest, cells. So what is a neural crest? Neural crest, it helps information of the neural tube. So cells from the neural crest, they also pass into these dermatomyotomes medially and laterally. This is a neural crest. A neural crest, it gives rise to the neural tube. It helps in the formation of the neural tube, and derivatives from the neural crest cells, I'll show you here again. The derivatives from the neural crest cells, they also pass medially and laterally. Now, neurons that develop from the neural tube or the spinal cord are known as motor neurons. The neurons that develop from the neural tube are known as the motor neurons, whereas the neurons that develop from the neural crest, they're known as sensory neurons. They are known as sensory neurons. Neurons arising from the neural crest are known as sensory neurons, whereas neurons arising from the neural tube are known as motor neurons. So these are motor and sensory neurons. Once again, the neurons that arise from the neural tube are known as the motor neurons, whereas the neurons that arise from the neural crest are known as sensory neurons. Clusters of the sensory neurons outside the CNS is called as a ganglion. And so what is a ganglion? A ganglion is a cluster of sensory neurons outside the CNS that is called as a ganglion. Now these sensory neurons, they carry information from the CNS to the body regions, to the peripheral regions of the body, and they're also known as general somatic efferents. It starts with an A. These sensory neurons, they carry information from the peripheral regions of the body. They carry information from peripheral regions of the body back to the CNS and are known as efferent. It starts with an A for apple, and are known as general somatic efferent fibers, or GSAs. These GSAs are general somatic efferent fibers, and they carry information from the peripheral regions of the body back to the CNS. Now the modalities carried out by these fibers are, they can sense touch, temperature, pain, and proprioception. Now when we say the word proprioception, it is the ability of the body to maintain the balance and posture that is carried out by these fibers known as the general somatic efferent fibers. Now the reason we're focusing on the A here is because we have another kind of fibers. They are known as efferent fibers. It starts with an E. Efferent fibers. Efferent and efferent. These efferent fibers are actually motor neurons. These motor and somatic neurons, these motor neurons, they carry information from the CNS to the skeletal muscles. From CNS to skeletal muscles. And are known as general somatic efferent fibers. We have general somatic efferent and general somatic efferent. So once again, what are general somatic efferent fibers? These fibers, they carry information from the peripheral regions of the body back to the brain and the spinal cord, whereas efferent, or the general somatic efferent fibers, they carry information from the CNS to the skeletal muscles of the body. We move on to dermatomes. So what is a dermatome? A dermatome is an area of skin that is supplied by a specific spinal nerve, or a specific spinal cord level. Cells from specific somites, they develop into dermis at very precise locations. Cells from specific somites they develop into dermis of skin. They develop into dermis of the skin at precise locations. The somatic sensory fibers that are associated with these specific somites, they enter the spinal cord from the posterior side and become a part of the spinal nerve. So the somatic sensory fibers, that are associated with or to a specific somite they enter the spinal cord at the same level of the specific somite. They enter the spinal cord, at the level of the somite, and it becomes a part of the spinal nerve.